Dr. Hill surveyed 40 students to determine their favorite cafeteria food. The results of the survey are shown on the table. Use the table and the scenario for the next few questions. What is the probability of pizza being a student's favorite cafeteria food? Well, pizza was liked by 3 out of 11 plus 3 plus 6 plus 15 plus 5 students. So 3 out of 40 students. That does not simplify, so we'll simply report our answer. 3 out of 40 equals 0.075, which equals 7.5%. And we can move on to our next question. Of the 360 students in 7th grade, how many would you expect to choose pizza as their favorite? So we still know that 3 out of 40 prefer pizza. We want to know how many of the 360 7th grade students would like pizza. So we're going to cross multiply. 360 times 3 is 1,080. 40 times x would be 40x. So we will divide both sides by 40 so we can get x all by itself and determine that x equals 27. So it would be likely, and we could predict, that 27 out of 360 7th graders would choose pizza as their favorite food. Part C. How many of the 1,200 students in the school might prefer hamburgers? Well, hamburgers, there were 15 out of the 40 that liked hamburgers. And now we want to know how many out of the entire school of 1,200. So 1,200 times 15 is going to be 18,000 equals 40x. So now we will divide by 40 on both sides and determine that our value of x is 450. So 450 students would prefer hamburgers. Suppose that on average, a baseball player makes about 3 out of every 4 foul shots. In other words, she has a 75% chance of making each foul shot she takes. Describe a simulation that could be used for this situation and provide expected outcomes for the first 5 shots. So she has a 75% chance. I'm not going to provide my expected outcomes because I'm not actually going to do this simulation, but you will. So you need to give me an example. Could be a spinner. Could be a deck of cards. If you're going to use a deck of cards, you need to give me a scenario that identifies the 75%, like drawing hearts, diamonds, and spades. That would account for 75% of the cards. Then you could randomly shuffle them and pull out the first 5 cards with replacement. And then the question asks, number 30, why would you use a simulation? And we talked about in class, you use a simulation for events that are difficult for you to actually do experiments with. You want to somewhat simulate the potential outcomes without having to do a full-scale experiment like in a factory or in trying to predict a weather scenario. Simulations would be done using calculated inferences and modeling objects that have the same probability as the mathematical calculation of probability for that given event.